So 575, generally around 10 questions will be there. That is a standard pattern. But they may increase this exam because 510 they changed a trend now. See, here equal 575. 510 we have 572. For 510 exam we have 572. If you go 570 exam we have 574. Okay, let's talk about this is a recommended practice actually. Okay. So this is the recommended practice, AP recommended practice. If you don't have experience in storage tank and you want to know how the storage tanks are constructed, how they are instructed, when you have time just to go through this book. It will give the detailed explanation about what is meant by bottom, how the shell, what is the different type of roof, what is the different type of internals we have, everything will be given in this. Okay. But before exam point of view, they used to ask around 8 to 10 questions. But the last year they changed the trend, not yet in 653, but in 510 they have changed it. 572 they are asking more questions. So they may follow the same pattern in 653 also. That's why we have marked more detail now, more area we have marked it. Before I used to cover maybe within 1.5 hours this code book. Okay, so today we'll take it more than 2 hours. So please take. See, generally the standard pattern so far is around 10 questions. But this time we are expecting there may be increase in the question in this code book. If they are increasing here, the number of question in 653 will be reduced. 653 and 570 will almost same will be repeated. Actually, it is just a revision. It looked like a revision only. A revision of 653. Okay, so please highlight page number 4. What is meant by alteration? It is a closed book question, mark it as a closed book question. So the definition of alteration is any work on a tank that changes the physical dimension or configuration in accordance with the AP 653 guidelines. So alteration means which will change the physical dimension. I told you the definition for alteration is revised now. In the previous edition, nozzle greater than NPS 12 inch is considered as a alteration. Now they changed in 570 as well as 653. Okay, now as per the latest this one, alteration means only the increasing or decreasing the shell height. Okay. Applicable standard we already know. This all repeat we will not highlight it. Only additional thing will highlight. What is meant by change in service? This is very important. This question, what is the change in service? A change from previous operating conditions involving different properties of the stored products such as specific gravity, corrosivity, or different service conditions of temperature. And again, understand, change in service may be a severe service or it may be a non-severe service also. So change in service means if you are changing the operating condition or stored product, change in service. What is meant by severe service? Storing a product with a higher specific gravity or decreasing the design metal temperature. These are considered as a severe service. How to evaluate the severe service? We have to do the hydro test. If it withstand the hydro test, it will not fail during the severe service. The reason is why we are doing hydro test. We are using hydro test water. Water specifically it is 1. Most of the product we are storing oils, specific properties also is less than 1. Okay. Then what is meant by CML? I think this is a new terminology. Okay, but it's not related to tank. What is the CML means? See, when you are monitoring what are the different type of inspection we have in as per 653? Routine in-service inspections. What is routine inspection inversion? Every month it is conducted by operator on the ground level, he will check. Next one is called external visual inspection. Okay, external visual inspection also without NDT. What is the formula for external visual inspection? Lesser of 5 years or RCA by 4 years. Third one is the UT thickness measurement. UT thickness measurement, what is the formula? RCA by 2N or 15 years, whichever is less. Now, apart from this, what is meant by CML? In tank area, Suppose you think this particular area we have to regularly monitor by using NDT. It may not be only thickness gauge. You can do PTMT. This area fatigue cracks is coming. This area stress corrosion cracks coming. This periodically monitored areas are called CMLs. CMLs means condition monitoring location, where you are monitoring condition by using various NDT methods. So highlight this one. Designated areas on tanks where periodic examination are conducted in order to directly assess the condition of the tank. CMLs may contain one or more examination points and utilize multiple examination techniques. Actually, these are not important for storage tank. They are piping and pressure vessel related terminology. Then what is meant by damage mechanism? Highlight this one. Any type of deterioration, mark it as a open book, encountered in the refining and the chemical process that can result in flaws or defects that can affect the integrity of the tank. Then defect. You know what it already defect. Defect means a rejectable discontinuity. An imperfection whose type exceeds the applicable acceptance criteria and therefore rejectable. So what is meant by examination? Please, as per API code, this is NDE. So all normally we call it as a NDT. They are called as a examination. As per code, what is meant by testing? Hydro test, pneumatic test, or leak test, and to check the integrity of the tank, or mechanical test. They are considered as testing. NDT is not considered as testing by ASME and API codes. Then fitness for service, very important closed book question. A methodology where flaws and other deterioration or damage or operating condition contained with a tank are assessed in order to determine the integrity of the tank for continuous service. General corrosion that is distributed more or less uniformly over the surface as opposed to localized corrosion. Indication. What is meant by indication? The response of the NDT. NDT showing something. A response or evidence resulting from the application of NDE. Mark it as a closed book question. Then these are not important. Jurisdiction. What is meant by jurisdiction? A legally considered government administration that may adopt rules relating to tank. Localized corrosion that is largely confined to a limited or isolated area of the metal surface of the tank. Then this is open book question. What is meant by minimum acceptable thickness? The lowest thickness at which a tank component should operate as determined by the parameter in the applicable tank design standards such as 650, 653, etc. And the fitness for service. So what is the minimum required thickness? We call it as in a tank minimum acceptable thickness. Out of service. So what is meant by out of service? Designate that a tank is clean and empty of product. A tank during original construction, removed from service and cleaned or returned. This is all out of service. If it is an empty tank, retired tank during construction, this all considered as a out of service. The next page, what is meant by product side? The interior surface of the tank bottom, usually used when describing the corrosion. Another term for the same meaning is top side. So top side, inside, product side, all are same. Underside, bottom, what is called soil side, these are same. Then RBB, release prevention barrier, that is a closed book question. Steel bottoms, synthetic materials, clay liners, and all other barriers are combination of barriers placed in the bottom of or under the above ground, which have the following function: preventing the escape of the contaminated material and containing or channeling the released materials. Repair, this is important closed book question. Any work necessary to maintain or restore a tank condition suitable for safe and leak-free operation. Soil side, the exterior surface of the tank bottom, usually used when describing corrosion. Other terms are underside, bottom side, all are same. Then sounding. What is meant by sounding? Doing a hammer test. By sound, we can find out whether the thickness is reduced or not by hearing the sound. An inspection technique that relies on impacting the market as a closed book question with a tapping rod and listening or for hollow sounds that indicate delamination or loss of discontinuity. Then who is storage tank engineer? An engineer acceptable to the owner operator who is knowledgeable and experienced in the engineering discipline associated and evaluating mechanical and metal characteristics. Then temper repairs. Repairs made to storage tank to restore sufficient integrity to continue operation until permanent repair. Mark it as a closed book question. But we didn't discuss anything about the temper repair in 653. Because I told you during the 653 class, the difference between pressure vessel piping will be in one side, storage tank will be other side. In pressure vessel and piping, all fillet weld patches are considered temporary repairs. So they should be replaced in the next shutdown. But in storage tank, fillet weld patches are considered as a permanent repair, provided owner operator approves that. In piping and pressure vessel, they never considered as a permanent repair. They are just for time being. Okay, so tank la vandu fillet weld patch permanent. Then water bottom, see definition of bottom sediment and water. Bottom sediment here. So I forgot to highlight. Please go to the 3.6 bottom sediment and water. This is important. Bottom sediment that may settle out in the existing non-agitated portion of the tank at the bottom. Mark it as a closed book question. Forget to highlight it. Yeah. See, why if when you are storing the oil, even if you purchase oil for your home, you can see at the bottom of the bottle, you can see some what you called kachada, we call it unwanted material storing. Same way, tank bottom also will have a sediment, that is called sediment. Water, how water enter the bottom? Sometimes when you are using a crude oil storage, when you are exploring the oil, there is always water will also come with that. So water, because of the higher specific gravity, they will store at the bottom. One. Another one, if you have a processed oil storage tank, not a crude oil, processed oil, what will happen if any rain leakage, when the rain, there is any leakage in the tank, any leakage in the drain pipes, or they will mix it with oil because oil, they will not dissolve with oil. Oil will not drop, they will come and settle at the bottom. Bottom water and stand. So we will go to that is about the terms. Type of storage tanks. 4.1.1. Highlight the last line. Guidelines for inspection of pressure vessel operating at pressure greater than 50 psi are covered in 572. You remember during the introduction class last week I told 650 covers only atmospheric above ground storage tank. Atmospheric storage tank it covers, above ground storage tank it covers. But there may be a internal pressure. What is the maximum internal pressure allowed? 2.5 psi. Vacuum, how much allowed? 0.5. 0.5 or 0.25? 0.5. Okay. Vacuum. Okay. Now, if the pressure is more than 2.5, up to 15 psi, it is covered in APA 620. 620 is the low pressure storage tank. But if the pressure is more than say 15 psi, it is covered in pressure vessels. We have to follow the pressure vessel rules. Okay, this is the one. Guidelines for inspecting for greater than 50 psi. 572 is the pressure vessel fabrication. That's temperature. Next F. Storage tank. M on the pressure, but this one is 620. Low pressure storage tank, it will come in the storage tank. Temperature. Okay. Now please go to the 4.1.4 storage tanks with the auxiliary equipment. 4.1.4 next page. This is important. Most storage tanks are provided by some of the following auxiliary equipment, such as what is meant by auxiliary equipment: liquid level gauges, high and low level alarms, and overflow prevention system, pressure relieving device, vacuum venting, emergency events, gauge hatches, roof drain, flame arrestor, and mixing device. Then stairways, ladders, platforms, handle, piping connection, and walls, manholes, electric grounding connection, and catheter protection are considered example of auxiliary equipment. These all are considered auxiliary equipment. That is closed book question. What is meant by auxiliary equipment? This all are considered as a auxiliary equipment. Then atmospheric storage tank. 4.2.1. Highlight the first three. Atmospheric storage tanks are designed to operate with internal gas or vapor space at a pressure close to atmospheric pressure. Such tanks are usually constructed of carbon steel, alloy steel, aluminum, or other metals, depending on the service. See, you remember I told when 650 came into picture, 1961. Before that, it was API 12C. But apart from 12C, we have 12A, 12B, 12D, all this. What is 12A, 12B? Belted tanks, riveted tanks. Okay, like that. So you can see here, these are not important. Generally welded, some riveted tanks, to riveted tanks 12A, and bolted tanks 12B. Okay, and 12A now it is withdrawn. 12C, this is now changed to 650. 12D, 12B all withdrawn. Now they are not in this. Now, use of atmospheric storage tanks. Where we use the atmospheric storage tanks, where we use a low pressure storage tank. It depends on what product you are going to store it. So highlight this one. Atmospheric storage tanks in the petroleum are normally used for fluids having true vapor pressure less than atmospheric pressure. That line is important. So atmospheric pressure, vapor pressure should be less than atmospheric pressure. Huh? Then vapor, what is vapor pressure? Abhina? See, when you are storing oil, this will evaporate because it is a closed structure. There will be a pressure built up. Vapor pressure is the pressure on the surface of a confined liquid caused by vapors of the liquid. Vapor pressure increase with increasing temperature. Crude oil, heavy oils, gas oil, furnace oil, naphtha, gasoline, and non-volatile chemical are usually stored in atmospheric storage tank. That line is important. So atmospheric storage, what type of oils will store? Crude oil, heavy oil, gas oil, naphtha, gasoline oil. Many of these tanks are protected by pressure vacuum vents that limit the pressure difference between the tank vapor space and the outside. So pressure vacuum vent will open automatically. We have seen in AP 576. Extended matching, I told there are three other patterns. So one is a multi-choice, another one is multi-response, third one is the extended matching, fourth one is a drag and drop. It was asked in the extended matching, which product we will store in atmospheric storage tank. So this is the list. Low pressure, it is given later. Low pressure, what products we can store? We have to match it. Next, atmospheric. 4231, cone roof tanks. This line is important. This line is important. The most common type of atmospheric storage tank is the fixed cone roof tank. So most common atmospheric storage will have a fixed cone roof. That line is important. Fixed cone roof tanks are typically up to 300 feet in diameter and 64 feet height, although larger diameter has been built. Next one is a open book. These roofs are normally supporting by internal structures, rafters, girders, and columns. So generally they will have a columns supported on the bottom, but can be fully self-supporting in smaller diameter, typically 60 feet or less. That is open book question. Self-supporting aluminum dome roofs may be applied to most diameter tanks without the need of internal supporting function. So what is the difference between self-supporting and internal support? Internal supporting tanks will have columns. Self-supporting will not have columns. They will have only girders and the rafters. Okay. Then, so you can see picture here. This is a cone roof, how it looks. Next page is, this is umbrella roof. Then external floating roof. Highlight this one, close book question 42331. The floating roof tank is another common type of atmospheric storage tank. The floating roof tank is designed to minimize filling and breathing losses by eliminating or minimizing the vapor space above the stored liquid. That is important. Close book question. Then this line is open book question. Older type external floating roofs include a single deck designs without annular pontoons. The external floating roof type is no longer permitted by 650 Annexure C. So we need a pontoon. Older type will not have a pontoon. This is not allowed by, this is important. It is what was asked in the last exam. Mark it as a open book question. Important. Mark it as an open book. Such roof has no reservoir buoyancy and are susceptible to sinking of the surface. Then highlight this one. This is a closed book question. 42332, next page. Some floating roof tiers have fixed aluminum geodesic dome roofs installed on top of the tank shell to reduce the product vapor loss or to eliminate the need for drain water. So there will be, it will not allow the water. These are considered internal floating roofs for the purpose of emission control, confined space, and the etc. So internal floating means there will be fixed aluminum roof and a floating. Close book question. So you can see here, this is annular pontoon. Its center there will be plate only. This will be the pontoon. Pontoon means which will float to the roof, and this is the complete double deck pontoon. Now highlight this one, 42333. Floating roof sealing systems are used to seal the space between the tank wall and the floating roof, typically with a mechanical seal. The type of seal consists of a shoe that is a plate pressed against the tank wall by springs or other tensioning system with a flexible vapor membrane attached between the shoe and the floating roof outer rim. One alternative seal detail occasionally still found in the exit tank is the shield shown in figure 12. These tubes are filled with the solid foam. Foam filled are still there, which inside there will be filled with the foam. Then, so this is the floating chute seal. So you can see it will have the plate will press against the shell so that there will be no vapor loss. This is the foam filled. These are not important. Please go to the page number 23. Low pressure storage tank, 4.3.1. Highlight this. This is closed book question. Low pressure storage tanks are designed
Sir,
to
one
operate. Yes, please.
Sir, no need to mark the internal floating roof, sir.
No need to mark. We
Okay.
will just skip because only maybe 10 questions.
Okay.
That are those designed to operate with the pressure exceeding 2.5 psi, permissible by 650, but not exceeding 15 psi. That is the 620 maximum for limitation of the 620. Okay. Use of low pressure storage tanks. Now this is important. You know what we store in the atmospheric storage tank. What we will store in the low pressure. Highlight this one. Low pressure storage tanks are used for the storage of more volatile fluids having a true vapor pressure exceeding in 650 but not more than 15 psi. Light crude oil, gasoline blending stock, light naphtha, volatile chemicals, LPG, LNG, liquid oxygen. This all we can store it. So mark it as a open book question. Then types of low pressure storage tanks. Highlight this one. Tanks that have cylindrical shells and cone or dome roofs are typically used for pressure less than 5 psi. This is about the low pressure. Tank bottoms may be flat and have shape similar to the roof. Hold down anchorage at the shell is generally required for pressure above 5 psi. Hemispheroid, spheroid, and nodded spheroid tanks types are commonly used. So what is a hemispheroid? You can see that this one. This is the hemispheroid. Okay, this is called hemispheroid. Next page we can see here. This is the nodded hemispheroid. Then this is the plain spheroid sphere. That is a sphere, we call it as, and this is the plain hemispheroid with the knuckle radius of. And this is called again noded spheroid. Okay, these are not important. Then please go to the chapter 5, 5.1.1, reason for inspection. Page number 28. This is important closed book question. The basic reason for inspection are to determine the physical condition of the tank and to determine the type, rate, and cause of damage mechanism and associated deterioration. That is the basics for the inspection. Physical condition and what type and what rate there are damage mechanism happen. Then process safety, highlight 5.1.2. One of the primary reasons to conduct periodic scheduled inspection is to identify the deficiencies that could result in a process safety incident such as loss of containment, which could lead to fire, toxic, or other environmental hazard. These deficiencies should be addressed as soon as practical through evaluation, further inspection, or repair. The next page, regulatory requirements 5.1.4.1. This is important closed book question. Right. In general, regulation means local government rules. Local government require the compliance, the industry and the standard to adhere to the recognized and generally accepted good engineering practice. That is called RAGA JEP. When performing any inspection and repair activities, many regulatory groups, including OSHA, PHMSA in the United States, require that operating companies follow internal procedure. In addition, this last line is important. So we have to follow the company internal procedure in addition to following the course. These are not important. Then 5.2.1, deterioration of the tank. Highlight this one. Corrosion is the primary cause of the deterioration of steel storage tank and accessories. Locating and measuring the extent of corrosion is a major reason for storage tank inspection. If left unchecked, tank deterioration can progressively lead to failure, which may have adversely affect on endangering personal or the public, environmental and property damage, and business interruption or damage to reputation. Now we will go to the 1 by 1 portion. So this is actually almost our revision of the 653 now. Many things we have already seen in 653. Atmospheric corrosion. Atmospheric corrosion can occur on all metallic tank components exposed to atmosphere. The type of tank, construction details, environmental condition can all affect the location, extent, and the severity of external corrosion. For example, a sulfurous, acidic, and marine atmosphere can damage protective coatings and increase the rate of corrosion. External surface of the tank and auxiliary equipment will corrode more rapidly if they are not protected with the coatings. Where surface are in contact with the moisture or the ground, extended contact with the water is likely to cause localized corrosion. Okay, now before there was a sentence here which is now removed, that if you suppose you are in India, you are want to construct a house. So we will generally call the, suppose you are having house, what will they will ask which facing the house? South facing, east facing, north facing, west facing, like that. Now which facing house will receive more sunlight? Which facing house? I will put it like this: when you are traveling in a bus, which side you will sit, which side you will sit, will receive more sunlight, very hot. East side or west side? Forget about north and south. West side. It is always west facing house. The sunlight will be west facing house will be very hot actually. The reason is after 3 o'clock sunlight will come enter the house. East facing, the advantage is up to 9 o'clock the sunlight will enter, but after 9 o'clock the sun will not that much hot. Same way, if you take a tank, there was a sentence before, I think your question bank also covered this, now it is removed that. Which side receiving more sunlight will have more atmospheric corrosion? We have a tank, which side we have more sunlight? And which side we receive more rain will have more CUI problem. மழை அடிக்கிறது ஒரு டைரக்ஷன்ல தான் அடிக்க பாத்துறீங்களா? எப்பயுமே ஆப்போசிட்ல அடிக்காது நம்ம மழை. When raining, it will be only from the particular direction only it will come. So if you have a tank is a large structure. So generally rain, if there is a rainfall, it will only one side will be more affected by rain from the other sides. If you take four sides, south, north, east, west. So which side will receive more sunlight will have more atmospheric corrosion, and the side which will receive more rain will have more CUI problem. But that sentence they removed now for the atmospheric corrosion, the sunlight point. Okay. I think your question bank, we have a question, but we will remove that question. Tank bottoms. External corrosion of tank bottoms can be significant. The foundation metal used for forming a pad is directly in contact with steel bottom can contain metal that promotes corrosion. For example, cinder. What is meant by cinder? Small coal blocks, cricket, small coal pieces. If they, because cinder have carbon, if they are directly in contact with the tank bottom, they can cause a pitting corrosion and it will become a hole in the future. This is very important. Cinder is to non sulfur compound that become very corrosive in the presence of moisture. The presence of clay, wood, gravel, or crushed stone as a contaminants in a sand pad can cause pitting corrosion at the each point of contact. That will cause pitting corrosion. That is closed book question. Now CUI, highlight this one 5223. External corrosion also occurs when insulation absorbs ground or surface water by wicking action, or when damaged or improperly sealed openings. For further information, refer 571 and 583. In case where the wall of the tank is partially below grade, the inspector special attention of the soil in interface for oxidation. See, CUI is covered in 571 as well as 583. Highlight that line. See, 583 talks about the CUI. Remember, 577, it talks about the metallurgy. We will, maybe tomorrow or day after tomorrow, we will cover. See, you have to remember some standard names, maybe rarely one question. I think 653 generally they are not asking. 577, metallurgy, welding indeed. 578, API, these are API codes. API 570 covers material verification program, or normally we called as a PMI. 579, fitness for service. 580, RBI, risk-based inspection. 581, RBI methodology. So RBI have two code books. 80 covers RBI principles. 81 covers the methodology, which methodology you are going to use. 582, it covers the harness test, mechanical testing. 583 is cover the CUI. 584, it covers IOW, integrity operating window. What is meant by integrity operating window? What the range allowed during the operation. Okay. The next page, reverter tanks. See, still you can have some reverter tanks. Suppose reverter tanks, I think 653 it covers. Reverter tanks, from the revert 6 inch away, we take it as a efficiency 1. You remember, for welded 1 inch away, we will take AVE is equal to 1. Reverter tank 6 inch away, we will take it efficiency 1. Now this line is important. Reverter tanks have many niches where concentration, because revert there is a gap, then there will be a concentration shell corrosion. Leaks at the seams of reverter tanks can failure of the external coatings, allowing external corrosion to develop. Suppose there is a leakage, it will affect the painting also, coating also, then it will cause corrosion. Then internal corrosion. The occurrence of internal corrosion in a storage tank depends on the contents of the tank and the material of construction. What you are storing and what is the material. That is the one. That is closed book question. Now next one is product vapor and BSW. Now, if you take a storage tank, see, suppose by storage tank, the underside, what corrosion will happen? This side, we call it as a soil corrosion. So soil corrosion, that's why we are going for a cathodic protection. And what corrosion this side happen? This is called bottom sediment and water corrosion. For that only we are going for a lining. Generally, shell will not be affected by corrosion, because most of the oil, if you are storing oil, they are non-corrosive. But still there may be a corrosion, but not very severe corrosion. That's why if we take a pressure vessel, shell is the most important component of a pressure vessel. But storage tank shell is not a most important. The most important is the bottom. But here there can be a portion. Suppose this is my roof. This is my roof, and my fill level is only up to here. This area there may be a portion. This is called as a vapor space. So vapor space due to the oxides. Okay, they can evaporate. Okay, that oxygen and other oxides can promote a corrosion. So these are the important. Crude oil and petroleum product tanks are usually constructed of carbon steel. Internal corrosion of these tanks in vapor space above the liquid level can be caused by H2S vapor, hydrogen sulfide vapor, water vapor. Open the question, these are oxygen or any combination of these. In the areas in contact with the stored liquid, corrosion is commonly caused by acid salts, hydrogen sulfide and other compounds. Dew point corrosion or contaminated water that settle out and mixes with the solids, typically referred as BS and W, bottom sediment and water. So vapor space, we will, because of the hydrogen sulfide vapor, water vapor and oxygen or combination of this. Bottom side, because of hydrogen sulfide, other sulfur compound, dew point corrosion and contaminated water, they are referred as a bottom sediment and water. That two, the both are open to question. Linings. So some tank we can have a lining. Lining, what is the purpose of the lining? To protect the bottom from this one. In some particular corrosive service, it may be necessary to construct your tanks with more resistance such as aluminum, stainless steel. These experience deteriorates from less common and cost. These are not important. Leave it, leave it. Now we'll go to the wooden tanks. Wooden tanks are very rare now. Wood tanks, the older tanks. Okay, but wooden tanks are generally used for storage of food products, like fruits. You want to store this food product storage. Yeah, but the problem with the wooden tank is termite. They can cause, they can damaged by the termite. Termite. Another one is what will happen if it is a wooden tanks should be kept wet. If they excessively dry, they may crack also. Okay. Tanks constructed of wood can rot unless they are adequately protected. They can also deteriorate from the infestation by insects such as termites. Unless kept continuously moist, these tanks can shrink and can leak when refilled. If steel bands are present, the bands can subject to atmospheric corrosion and it can loosen under the repeat. See, generally, it is a, you can see in your house. If you have a wooden tank, it will become tight in the winter season because it will absorb moisture. You can see the wooden doors will be very difficult to close in during the winter, okay, raining season. Whereas if you have steel tanks using your bathrooms, they will become more difficult to close or open during summer because steel will absorb heat and expand. Steel tank, steel summer la close பண்றது கஷ்டமா இருக்கும். Woodenலாம் வந்து winterல பிரச்சனை. Right. Now,
so they're saying that the wooden tanks need to be moisture all the time in order to.
Yeah, moisture. ஏன்னா dry ஆயிடுச்சுனா திருப்பி இதா லீக் ஆக ஆரம்பிக்கும், crack ஆகும்.
But if it's going to be so moist, it's going to be toughness going to increase, right, sir?
இது woodக்கும் toughnessக்குலாம் சம்பந்தம்லாம் கிடையாது சார். இதுல ஒன்றும் இது கிடையாது. டஃப்னஸ்ங்கிறது இம்பாக்ட், இதுல இம்பாக்ட் லோடே கிடையாது. டேங்க்ல அந்த டஃப்னஸ்ங்கிற கான்செப்டே இல்லை. ஓகேங்களா? ரைட்.
சொல்றேன் சார், மெட்டீரியல் டஃப்னஸ் ஆகுங்களா சார்?
மெட்டீரியல் தான் வரும், வுட்டுக்கு வராது.
வுட், ஐ மீன் வுட் தான் நம்ம மெட்டீரியல் யூஸ் பண்றோம் சார்.
இல்ல, வுட்டுக்கு அந்த இதெல்லாம் கிடையாதுங்க. வுட் வந்து எப்பயுமே டஃபர் தான். ஓகே. Concrete tanks can be attacked by tank contents, crack because of the ground settling or temperature changes, or spoil due to atmosphere. You remember 653, concrete can fail due to calcining. What is meant by calcining? Excessively dry, it can absorb moisture and swell and break. Another one is cracks. So cracks are not very serious unless they become open, wide open. Okay, resulting in exposure to steel reinforced for atmospheric corrosion. Then non-steel metal tanks. So tanks constructed of metal, aluminum, stainless steel, and other alloys are usually used for special purpose, such as food processing. Generally, food processing, they are using stainless steel nowadays. Before you can see they used to aluminum. Patrikla Palkar, the milkman, they used to the aluminum cans. Now everywhere we are using plastic. There is a different thing. But aluminum can affect by impurities such as acid or mercury compounds in process streams or wastewater. That line is important. Close book question. Aluminum will be affected by acids and mercury. That is important. Then brittle fracture. Highlight this one, 5.4.2. Brittle fracture and sudden loss of contents of a tank can result in injuries to personnel and extensive damage to equipment in surrounding areas. So sudden, see what is the problem of brittle fracture is, it will be a sudden rapid failure without any deformation. It will break like this. It can result in a catastrophic failure. Catastrophic, sudden problem. Which one? Yeah, it is like almost revision of 653 one. Yeah. The next page, cracks. Crack-like flaws can result from a number of causes, including deficient design, fabrication, and maintenance. The most likely points are crack-like flaws occur at the bottom to shell details, around a nozzle connection, manholes, around revolt codes, under rivet heads, and welded brackets. Then this line is in open book. The lower shell to sketch plate or shell to bottom weld is especially critical because in relatively large or hot tanks, there is a higher likelihood in this detail to develop crack-like flaw due to high stress. So the shell to bottom weld is highly critical. I told you sketch plate means if you are not using an annular plate will have a higher thickness than the bottom plate. If you are using same bottom plate to weld with the shell, that plate is called a sketch plate. So you can see here, so the shell to bottom weld crack, it is very dangerous. Immediately it should be repaired. Then please go to the page number 5.46, settlement. Third line, 5.46. Large or uneven amount of settlement can cause nozzle with attached piping to become overstressed and possibly deformed or cracked or interfere with the normal operation of the floating group. Significant amount of uneven settlement should be cause for concern and for further investigation. That line is important. Then this also highlight edge settlement in tanks with cone down bottoms can trap bottom sediment water, resulting in bottom and lower shell corrosion in this area. Soil and water can also retain against the external shell when such a settlement is present. Then fixed roof equipment. So what are the deterioration of the auxiliary equipment? Pressure and vacuum vents and flame arrestor can fail to operate for the following reason. That is open book question, important. So flame arrestors and pressure and vacuum, the presence of fouling material or debris, corrosion between moving parts and guides or seats, deposit of the foreign substance by birds or insects, formation of ice, accumulation of grid blasting material, the covering of the vent operating with the plastic of the plugging of vent openings, tampering by unauthorized person, improper setting of the pressure relief actuation set point or vacuum release actuation set point. This may be the reasons for not proper functioning of pressure and vacuum vent and flame arrestor. This is open book question. Then internal equipments. Equipment 552 second 5. Equipment for draining water from floating roofs can be rendered inoperable by plugging or by mechanical damage caused by debris, ice, or rotation of the floating. Suppose the drain pipe, if it is blocked due to some foreign material or due to, so it is not operating, valve is now not closing, opening properly, then it will be a rain will be stored on the floating roof, but it may sink. Okay. For single deck floating roofs, leakage of the tank contents into the floating roof can submerge the sink or sink the roof. Inoperative drains with installed plugs can cause enough rainwater to accumulate on the roof to sink the pontoon type floating roof. That is open book question. Shell attachments. Deterioration of auxiliary equipment such as ladders, stairways, platforms, wind girders, and steel stiffener can cause corrosion, wind or other external forces. Mechanical equipment such as mixtures, swing line pontoons, piping, diffuser, jet, nozzle, and other flow details nozzles can suffer from retain due to corrosion. Now we'll go to the developing an inspection plan. See, 653, it is not at all mentioned. Generally, if you are going for inspection, you should have an inspection plan. 653 is not covered actually. Then first question, who will prepare the inspection plan? It is a collaborative work of inspector, engineer, operation, then process, all proper will sit together and prepare the inspection plan. What the inspection plan will have? First one, where to inspect on the tank, which location we have to inspect, what type of inspection you are going to carry out, whether it is a UT thickness measurement or CML monitoring or external visual, then what NDT you are going to use, how much area we have to do the NDT, what are the cleaning requirements for the NDT, any previously marked repair is pending, if you are going to repair, whether hydro test is required or not, then when we have to do the next inspection. Everything will be written in the inspection plan. So the inspector should carry the inspection plan and fill everything, complete everything. Okay, highlight this one. An inspection plan is often developed and implemented for tanks within the scope of 653 through the collaborative work of inspector, engineer, correction specialist, and the operating personnel. That is important. Close book question. Then the fourth line, knowledge of capabilities and limitation of ND techniques allow the proper choice of the examination technique to identify particular damage mechanism in specific. The plan should typically define the inspection needed, external thickness NDE, then highlight the identify the regulatory intervals or other component inspection needs, describe the inspection and NDE techniques, extent and location, describe any service cleaning requirement needed for the inspection examination, describe the requirements for any needed pressure and tightness test, describe any required repairs. And operation. See, generally, the AP 653 inspector should periodically communicate with the operation. Suppose because operation is the one who is continuously monitoring the tank. Suppose they face some problem, they have to inform the inspector there is a problem in that area. So inspector should, okay, he should prepare himself. Okay, there is a possibility there may be some corrosion or expected severe corrosion. Highlight this one. Ongoing communication with the operating personnel when process changes or upsets occur that could affect damage mechanism and rates are critical in keeping the inspection plan updated. Other common issues inspection plan include describing the type of damage mechanism anticipated and experienced during the defining the location of damage, defining the special access requirement. Then first, before starting inspection, what the inspector should know the prior history of the tank. Prior history means how many years the tank is in operation, what product it is storing, what were the past problems, everything. Prior to conducting internal or external, the inspector should thoroughly review any available inspection record to become familiar with the previous problem and the recommendation noted. That is important. Then please go to the 6.2.3 inspection methodologies. This is open book question, again important. Robotic inspection is one possible approach to perform an assessment of the tank bottom or the other internal component without personal entry. Unmanned aerial vehicles, UAVs, or drones can be utilized for better access to rafters, therefore eliminating need for the man lift. And recently asked to open book question. How you can inspect the rafter from inside by sending drone. Now everywhere you are using drone. Even marriage functions, videography is now through drone. Okay, so drone can be used to check, because instead of making scaffolding and check the rafter, you can use a drone with the camera and the ground level. You can see what is happening in this inspection. Okay. Yeah, UAV, unmanned aerial vehicles we can use, or drones also. Then highlight this one, leak detection. This one, many of the technologies used for leak detection are defined in API 334. It was again recently asked to open book question. So leak detection methods are identified in API 334. Open book question. The next page, RBI. Now, what is RBI? Just I will briefly explain. So first, I told you there is a formula for RBI. You remember what is the RBI, or what is the formula for risk? Just for 5 minutes, no problem. Spending 5 minutes is worth only. Risk, probability of failure multiply by consequence of failure, or likelihood of failure multiply by consequence of failure. That is a formula for the risk. Okay. How RBI works? First, you have to understand whether you want to do inspection as per 653 or inspection as per 58. 58 is the RBI. Will be decided by owner operator, not by inspector. Who will decide? Owner. Okay. Suppose if you decide to go for RBI, so each and every storage tank, he has to assess the risk. So what is the formula for risk? I told probability of failure and consequence of failure. Now, what is meant by probability of failure? Probability of failure means what is the possibility for a leakage of the tank. Failure means leakage, that's all. No other failures are considered as a failure. Failure means leaking. Now, when a tank will leak, if we know these three conditions, we can predict the probability. For example, when how many years the tank is in operation? Suppose it is a new tank or old tank. Second one, what is the problem happening inside a tank? Only uniform corrosion or crack problem? Third one, when the last inspection was carried out, recently or long before. So you can see what is the probability. It is a number between 0 to 1. 0 means no probability, not at all possible, no leakage will come. 1 means 100% possibility. 0.5 means 50% chances. Probability or guess. Okay. Now, what I will do, I will make a matrix. Say, for example, I will take probability of failure in y-axis. It can be both ways, consequence on x-axis, and I will give some number. 1, 2, 3, 4, 5. 1 means very low, 2 means low, medium, high, very high. Very low, low, medium, high, very high. Same consequence, I will give A, B, C, D, E. Very low, low, medium, high, very high. Now, I will give you the case. A tank recently installed, only a uniform corrosion is the problem. Okay, inspection recently carried out will have a very low probability. So what is the very low probability number is 1. Suppose what you are storing inside is a non-flammable, non-toxic, like water storage tanks. Then the consequence also very low. So this 1A is called as a risk number. So we will give number, risk number is 1A. So if we will mark the tank like this, 1A. Then which tank will have a very high risk? 5E. So what RBI team will do? Each and every tank, they will assess the probability and the consequence. They will give numbers, risk number they will give. 1A, 1B, 1C, 1D. So the tanks will be marked in various locations. Like this. After that, the owner will put some lines. Any tank risk number is coming here all called as a high risk tanks. These are called as a medium risk. Now, these are called as a low risk. Okay. Now, what is the purpose of giving this numbering? First one, if you take APA 653, okay. So what is the thickness measurement intervals or external visual inspection? What is the external visual inspection? External visual inspection, what is the rule? External visual RCA by 4N. What is RCA? Remaining corrosion allowance. N is the corrosion rate. So if you put RCA by N, it will show remaining life. Actually, 1/4 of the remaining life you have to do it. But if you go here, so we have to do 5 years, whichever is maximum 5 years. But what APA 580 will say, if the tank is low risk, we can do after 20 years also. We will not follow the RCA N, nothing will follow. The inspection interval is based on the risk. Low risk item, we will increase the inspection interval. High risk item, we will decrease the inspection interval. So 580 is used to fix the inspection interval. Okay. Then only for inspection interval we are using 580. No, it will give more guarantee. Okay, it will give a more guarantee because we will go for a detailed inspection. You see one sentence in 653. For our risk-based inspection, spot UT thickness readings are not allowed. You have to scan the area. To predict the risk accurately, you should go for more NDT than the 653 requirements. Just to mark it because RB is not very important in 653. Generally, there will be no questions. So if you want to just write this, or otherwise you will come. Is it okay? Right. So highlight this one, risk-based inspection. Inspection plan based upon the assessment of risk associated with the tank failure by determining the likelihood of failure and the consequence of failure is referred as the risk-based inspection. That line is important. RBI can be used to determine the inspection interval and type and extent of future inspection examination. RBI 580 provides a minimum requirement that must be considered to carry out the systematic evaluation of both the likelihood and the consequence. So RBI 580 provides the minimum requirements. So RBI can be used to determine, and that line is important. RBI can be used to determine the inspection interval and the type extent of future inspection. Then probability of failure assessment. This is another important. Identifying and evaluating potential damage mechanism, current tank condition, and the effectiveness of the past inspection are important steps in assessing the likelihood of tank failure. The likelihood assessment should consider all forms of degradation that could reasonably be expected to affect the tanks in particular service. That is important. Open the question. Then consequence. Highlight this one. Identifying the process fluid, potential injuries, loss of containment, environment impact, and unit loss of protection are important assets consequent associated with the failure of the tank. The inspection plan. After an RBI assessment is conducted, the result can be used to establish the inspection plan and better define the following: the most appropriate inspection and NDE methods, tools, and techniques, extent of NDE, interval for internal, external, or on stream, and the prevention and mitigation steps. Just to highlight. Now we will go to the inspection timing. Chapter 7, 7.1.2. Last line is important. Holes in tank should be reviewed by the inspector or storage tank engineer and addressed immediately. That line is a closed question. If there is any holes in the tank, it should be addressed immediately by engineer and or inspector, and we have to immediately repair it. Then climatic events. For severe climatic events, high winds, this open book question, high water, heavy rain and lightning, potentially affected components should be checked. These components include but not limited to external floating roofs for excessive water load. After heavy rain, you have to go and check the external floating roof whether water is storing there. The foundation for deterioration, the external floating roof deck and seals to see if they have been damaged. The shelf or evidence of deformation due to excessive loading. This all we have to check after the heavy rain or high wind, all this. Seismic events. After seismic event that were significant enough to have impacted the integrity of the components, floating roof and associated tank piping and the inspection shall be performed. That's also important. Then opportunities for inspection coordinated with the operation issues. Highlight the third line. Internal inspection interval should be also based on experience and risk as determined someone knowledgeable with the tanks and its operation. In no case should the maximum interval of this inspection exceed in 653. The coordination requires knowledge of the internal inspection intervals and operating. So what is the interval as per 653? I told it 10, 20, 30. Generally, it will be every 10 years you have to do internal inspection, but you have some additional what you call the lining, or we can add that period. So maximum 20 years without a release prevention barrier. With the release prevention barrier, maximum 30 years. Then condition-based inspection. Inspection schedule and performed based on the past, current, and expected future condition of your tank are defined at the condition-based inspection. Highlight these two lines. Then correction rate your evaluation. Now, if you see the correction rate, what formula we are using here? T previous minus T actual divided by the number of years. Suppose if the correction rate, if you know, you can make a plot. There is a graph is given and find out when the next, what will be the thickness after 5 years also. Okay. For uniform correction, highlight this one. A correction rate can be estimated by plotting the metal thickness from 2 or more inspection against the inspection dates. An extension of the line drawn through the plotted points will provide an estimation of the line at which the metal which reach the minimum acceptable limit, assuming a uniform linear corrosion. In addition to natural variation, changes to corrosion such as operating condition, temperature, catalytic protection, and other factors should be investigated to determine the corrosion rate. I will show you. There is a picture. Okay, it's missing here. Okay, there is a plot. There was a plot. We can make a graph. I think it is in 653. Okay, leave it. No problem. Now, go to the next page. Service stresses. Page number 42. Highlight the fourth line, 7.313. Bottom areas away from the shell and rounded ring needed to be only thick enough to leak tight and be at or above minimum acceptable thickness for standard 653 at the next out of service. You remember other areas of the bottom, even next inspection, it will be 0.1 inch. But if you have thick film lining or release prevention barrier 0.05 inch is allowed. But critical zone, what is meant by critical zone? Around shell 3 inch and outside extension, there should be at least 0.1 inch. Even if you have release prevention barrier or what you called lining, anything, it should be minimum 0.1 inch. Then these are not important. So please go to the product consideration, page number 43. Storage tank shell plate thickness is normally calculated to obtain a fluid of a desired specific gravity, usually water for the hydrostatic test. So hydrostatic formula, we are using only water in the shell calculation. That's why there is no specific gravity is included in the hydrostatic formula. Then fourth line. Conversely, if the shell and walls are corroded, it may be necessary to reduce the allowable safe fill height of the tank or change the products to the one with lower specific gravity. Certain stored products may have specific gravity greater than 1, and the shell plate thickness will be designed accordingly. If the specific gravity is greater than 1, then a hydrostatic test condition does not affect the loading. So if you are going to store more than 1, you cannot use a hydrostatic test to prove the whether it will be acceptable or not, because what is the water specific gravity? 1. It is always applicable less than 1. Then minimum acceptable thickness for structural member. This is important. 7323. For structural members and parts such as roof supports and column platforms, normal accepted industry practice for structural designs, such as method provided in steel construction, can be used to calculate the allowable loads for the new condition. So what is the structural member thickness? Usually based on the normal accepted industry practice. We have to follow what is the normal minimum, this much thickness should have. Only follow this one. This is open book question. Then similar service methodology. So what is meant by similar service? I told only one tank, that is called a control tank, will go for complete internal and external inspection. Other tanks will go only external, no internal. The internal inspection interval for atmospheric storage tanks as defined by 653 is governed by the corrosion rate and tank bottom. Corrosion rate of the tank bottom, that line is important. Generally, internal inspection is governed by the corrosion rate of the tank bottom. Then next page 44, highlight this two line. Similar service is recognized within industry as a means for scheduling the internal inspection intervals in 510, 570, and 653, which use corrosion rate as the basis for establishing the inspection interval. Then 7.4.2 highlight the third line. Often, multiple inspection methods are utilized to establish the minimum bottom thickness. That is MFL with the follow to ensure that the worst area of soil side corrosion have been detected. When an owner operator chooses to apply similar service to estimate the tank bottom products and the soil side, the owner operator should consider the factor listed in B1. So we will see B1 later. Okay, highlight this one. When similar service evaluation is conducted for tanks on the same site, see, generally similar service we are conducting for soil side corrosion and inside corrosion. When you are going for inside corrosion, you can take a similar service tank in any other location also. But soil side corrosion only within the same site we have to take, because soil condition will change from location to location. When similar service evaluation conducted for tanks at the same site, it is important for the inspector engineer to realize there is always a possibility that soil side corrosion rates can vary from tank to tank simply by difference in QC in foundation material, potential for lumps of clay, pieces of wood, organic material, etc. Then this is the important soil side corrosion. Similar service evaluation of soil side corrosion rate is typically only useful for tanks located on given site. Only given site they may be useful. Then highlight this one. This 3 lines. Soil side corrosion from here. Data may vary from negligible to very aggressive pitting with rates approaching 20 mils per year. The best source of soil side corrosion rate come from the examination of previously inspected tank bottom from the same site. That is market as a open to question. Then inspection, please go to the 8.1.1 safety precautions. Before entering or re-entering any tank, Appropriate safety steps are necessary. That line is important. Before entering or re-entering, you have to follow safety. These precautions are discussed in APIs 2015. So we have to check API standard 2015. Generally, such actions include, but not limited to the following: isolation from any source of toxic or gas generating fluids in the use of blinds or disconnection, removal of hazardous liquid and gases, removal of gas generating pyroperic or toxic waste. See, what is pyroperic? It is a phosphorus. What is the problem with the phosphorus? Is a self-ignition. When phosphorus become dry, it will automatically catch fire. So what code recommends? Suppose you know that the stored product will have phosphorus inside a tank. Even after cleaning tank, when you are going entering, any corners phosphorus residue can catch fire. So what you have to do? That's why when you are going for inspection, you have to keep the tank bottom moistened. Water you have to just wash with the water, because it will not fire, it will not shoot ignition. And this is open book question. Assurance of atmosphere that contains sufficient oxygen where applicable OSHA and locally applicable safety agency for safety entry should be followed. Utilizing OSHA CFR 1910146 and 1926 would be appreciated if under the jurisdiction, and it's important. Open book question. Then tank cleaning, last slide. For relatively clean product service, water washing the internal surface may result in adequate cleanliness of the inspection, but it may be necessary to grid blast or high pressure water blast internal surfaces, and the welder seems to achieve the sufficient cleanliness. Then highlight this paragraph. See, when you are entering the tank, first you have to look at the top, whether any loose structures are there, which can fall. So first you have to check. உள்ளார போனே மேல பார்க்கணும். மேல இருக்கணும். மேல போய் அது எல்லாமே கரெக்ட்டா இருக்கும். The inspector shall make a visual inspection of overhead structural members, plate surfaces, and all support to ensure there are no loose rafters, large patches of loose scale, weakened support columns or brackets, and any other object that might fall and cause person injury. Then these are the tools list. These are not important. Then please go to the page number 48. External inspection of an in-service tank. Highlight the 8212 lines. Much of an external inspection can be conducted while the tank is in service to minimize the length of the time the tank will need to be out of service. Then this is closed book question. Ladder and stairway. Ladder and stairway should be examined carefully for corroded or broken parts. The condition of the ladder, vertical or rolling stairway parts and handles should be checked by visual inspection, and if appropriate by mechanical means such as pinking with the hammer test. Just or to determine whether these parts are safe for continued use. That is closed book question. The next paragraph, first two lines. Large tanks may have intermediate support stairways. When concrete pedestals are used for such support, they should be checked for cracks, falling, and other problems. Then highlight this one. Handles, fourth line, next paragraph, should be shaken to give an indication of their soundness. Particular attention should be given to tubular handles which may have corroded from the inside. Handle of the shake pani paagum. Then walkways. Walkways now we should say whether they are rough. Then highlight this one, last line. If the corrosion surfaces are coated, corrosion may exist under the coating film. Rust stains visible through the coating and the gentle lifting of the coating are evidence of such corrosion. Then platform. Suppose, see, generally platform, if you are using a steel platform, there is a dent in the platform, something fallen on the platform, there may be water is storing. The best way is no need to remove that and make a hole on the platform, so that there will be no water storing. It will come down. That dent ஆகி அந்த இடத்துல வாட்டர் தண்ணி தேங்கிச்சுன்னா என்ன ஆகும்னா corrode ஆகும். ஒரு drill போட்டா போதும். Okay, this is important. Low spots where water can collect should be checked carefully because corrosion may be rapid in such areas. Drain holes can be drilled in the area to prevent the future accumulation of water. Platform supports should be also measured to determine the thickness and should shape for buckling and other signs of it. Then foundation, next page, page number 49, second paragraph. Wooden supports for small tanks, stairways, and other accessories can be checked for rot, by tapping with a hammer, picking with a scraper, or probing a knife or ice pick? That is important. Open book question. Wooden support, how we will check? Then anchor bolt. So anchor bolt, how we will check? We can tap with a hammer whether it is shaking, or you can tie it to the nut. This is closed book question. A tap with a hammer to the side of the nut may reveal severe corrosion of the anchor bolt below the base plate. Severe damage may not be detected by such a test. Visual inspection can be aided by removing the nuts one at a time and supplemented by UT examination. Anchor bolt nut should be checked for a stuck fit or to the anchor chair top plate. So this is the anchor bolt. You have to check it. Next page. Yeah, these are the anchor bolts. Then grounding connection. So grounding connection should have low resistance. What is the resistance allowed is maximum 25 ohms. Highlight this one. The total resistance from tank to earth should not exceed approximately 25 ohms. AP 2003 provides information concerning the grounding tanks to prevent ignition from the state electricity, lightning strikes, or state current problem. That also to follow 2003. Okay, we'll have some 10 minutes of break. Ram, he wants a break. Okay, we'll have some 15 minutes of break. After break, we'll continue.
Thank you, sir.
Protective. So grounding connection, just to overlap it. The total resistance from tank to earth should not exceed 25 ohms. AP20 provides information concerning the grounding. Now, what are the protective coating failures? There will be generally 3 failures of the coating. One is called rust spots. You can see the rust spots. That means the painting is going to fail. Another one is called film lifting. It is not adhered properly. It is very difficult to see visually. You have to use some sharp tool to find out. Okay. Another one is called blisters, paint blisters. So highlight this one. Rust spots, blisters, peeling, and cracking of coating due to lack of adhesion are all types of common coating failure. Rust spots and blisters are easily found by visual inspection. Coating bond failure is not easily seen unless a blister has formed or broken. That is closed book question. Then next page number 51. So this is actually a repeat of alternatively, spots for the application of ND should be identified. Example, pulsed eddy current examination. CA is most aggressive in temperature between 170 to 230 in accordance APA 583, but can occur in 10 to 350 degrees Fahrenheit. Just to mark it as a open book question. So this is a new requirement they have given. 170 to 230, it will be more aggressive according to 583. No, that is that removed now from 571. Generally, it is 10 to 351. Then these are not important. So please go to the page number 53. Upper shell course measurement. 82923. See, if you have floating roof, above the floating roof, there will be one shell course, which will be exposed to sunlight on both inside and outside. That may corrode more. So this is important. In updating shell thickness, a special attention should be given the upper 24 inch of uncoated shells of floating roof tanks. This portion, this is open book question. 2 feet, upper 2 feet of the upper. This portion of the shell plates can corrode at a higher rate than the lower shell plate because of the constant exposure to the atmosphere on both sides. Yes. Coating. Okay, that's if it is a coating failure, there is a possibility. Okay. Then establishing the shell CMLs for general correction, highlight the last 3 lines, 82924. It is typical to set up CMLs on the top, middle, and the bottom of a given plate in easy to access locations such as near ladders or stairs. The CMLs do not need to be in vertical line, and because this technique is used to monitor general correction, repeating the readings at the exact same location is not critical. The general correction, what is the meaning of this? For general correction, any area you can take readings. But if it is a localized correction, only the particular area repeatedly you have to take readings. Condition monitoring locations. Okay, UT thickness is one type of CML, other cracking also CML. Then these are not important. So highlight the 82926. UT measurement should be taken only by trained personnel using a properly calibrated thickness measurement instrument and an appropriate thickness measurement procedure. Coatings can affect UT readings, and the examiner may need to compensate for the coating when recording the metal thickness measured. Modern ultrasonic pulse echo thickness scopes, when properly calibrated, allow direct metal thickness reading to be taken through the thin film. Then this is important. Who will maintain the record of this? This is the examiner employer. Close book question. The examiner employer should maintain certification records of the examiners employed, including date and results of personal qualification, and should make them available to the AP authorized inspector. Then highlight the stiffeners and the wind girders, first line. The outside stiffeners and wind girders of a tank can be inspected visually and by hammer testing. Then this is a last 3 lines are important, highlighted. If the magnetic particle method is detecting for cracks while the tank is in service, current flow prod technique should not be used because of the danger of sparks. For this type of examination, a permanent magnet or electromagnetic flow, that is yoke technique, should be used. Prod is not allowed when the in service tank. Then caustic corrosion, right? These 2 lines are important. If caustic or amine solution are stored in a tank and the corrosion specialist believes that the storage condition may warrant an examination, the tank should be checked for evidence of damage from caustic, sometimes referred as a caustic improvement or amine SCC. That line is closed book question. If you are storing caustic, you have to expect a caustic stress corrosion cracking. Where it will occur, it will be at the bottom heating units, because for caustic, we need a temperature more than 170. And the crack will start inside the tank, and it will be a through crack. There will be a white salt on the cracks. Caustic will be stored. The most probable place for this is around the connection for internal heating units or coils. This type of deterioration manifested by cracks that start on the inside of the tank and progress through to the outside. If this condition exists, the caustic material seeping through the cracks will deposit readily visible salt, usually white. Yeah, this is also closed book question. It will visibly white salt. Temperature more than 170, before 170 degrees. Because internal heating unit, there will have a temperature. Now, ethanol stress corrosion cracking. API Bulletin 939E provides the guidelines, identification, mitigation, and ethanol stress corrosion cracking. Mark it as a open book question. API 939 you have to refer. Then hydrogen blisters. So if a tank is storing hydrogen at its temperature is high, hydrogen go inside a metal, because hydrogen atom is a very small atom and it can bulge the metal, that is called blisters. How you will find the blisters? You can see visually. The best inspection method is using the flashlight, our torchlight, holding parallel to the vessel wall. They are found most easily by visual examination and by feel. Hydrogen blisters. Visual examination should be aided by use of handheld lighting or sufficient candle power, at least 100 lumens under low ampere lighting, holding the flashlight against the shell so the light beam shines parallel to the shell surface. Many small blisters found. They can running the fingers over the metal surface. Then page number 57. Please go to the page number 57. Cracks at the last three lines, 82961. Cracks at the shell to bottom joint should receive prompt focused attention as the joint is the most highly stressed joint in most tanks. And when such crack reaches a critical size, the consequence can be catastrophic because complete tank will leak. Weep holes, reinforcing plate. So when you have a nozzle reinforcing plate, there will be a small hole because during welding to allow the gas to escape. That is weep hole, telltale hole, whatever you call. It should be keep open. You should not close it by welding. You can use a cork or some grease like that, but it should not be completely closed by welding. இல்ல thread வச்சு பண்ணலாம் but weld அடிக்க கூடாது. Normally weep holes in reinforcing should not be plugged so that the pressure will not build up behind the reinforcing plate and a tank leakage underneath the reinforcing will be evident. The weep hole may be filled with a cork or grease to prevent corrosion. Then leaks are often marked by a discoloration in the area below the leaks. That is important. If there is a leak, there will be a change in color. Discoloration, there is a color will you can change in the color of the surface. Corrosion. Leaks are sometimes found by testing the tank. These are not important. That is highlight this one. Highlight this one. Deformation will normally be readily apparent through the visual inspection. Inspector should consider that there should be slight deformation near a welded seam or elsewhere in the shell. Deformation can be measured by placing a straight edge lengthwise against a vertical shear or placing a curved edge. That is a peaking, banding, all this. Deformation caused by the settlement of the tank, wind, earthquake, internal pressure in the tank due to defective vents, or relief valves on operating induced by vacuum, severe corrosion, all this. Then highlight the last paragraph. When the cracking is suspected, magnetic particle examination is the preferred method to use. In using this method, the seams to be inspected should be abrasive blotted or wire brushed cleaned. Sandblasting abrasive crit plastic. Okay, rivet inspection 8297. 8297. This is important. Open book question. If the tank is riveted or bolted construction, a visual inspection should be performed, and the number of randomly selected rivets or bolts should be checked for tightness and product leakage. Movement of the rivet or bolt should not be detectable. It may be advisable to postpone any physical testing until the tank is out of service, and the rivets or bolts can be checked on the inside of the tank. That is open book question. Then roof access. Now, how we will inspect a in-service roof? Okay, what code recommends? This is a recommended practice. Don't walk on a roof or fixed roof of your old tank. Suppose the roof is very severely corroded, it may not hold the weight of the inspector. So first you have to confirm what is the strength of the roof. So what code recommends? Use a wooden planks which will cover at least 2 rafters and walk on the wooden planks. Suppose you cannot put wooden planks, always walk on the weld. Because roof you are using a lap weld. Lap weld means there are 2 plates, so they will have more strength. Okay. Unless it is established, the roof will have the sufficient. Another thing is, roof should not be hammer tested. You should not hammer the roof. What will happen when you hammer the roof? In service roof means bottom side corrosion product will fall on the oil and contaminate the stored product. Okay. The roof or top head of a tank can be inspected for significant thinning by UT or even MFL scanning if the root condition is thought to have enough strength to withstand the weight of the equipment. If it is you can do MFL also on the roof if the roof has sufficient thickness. Then 4th line, suitable fall protection should be used when working on roofs. On a fixed roof, planks long enough to span at least 2 roof tops should be laid and used as walkways. Very important. Many exams this question is asked. At least until the safety of the roof is determined. In general, the inspector should always walk on the weld seams if they are present because of the extra thickness to available to support body weight. It's important. In addition, last line also important because of the possible existence of harmful vapors, the floating roof should be as high as possible if volatile liquid is in the tank at the time of inspection. So for inspection time, you have to keep the roof as high as possible. If it is at the lower, what will happen if there is any seal leakage? There may be poisonous gas will be coming. Then these are not important. Then please go to the floating roof drains, page number 60, 8 to 10.4. Drainage system on floating roof should be inspected frequently for leakage and blockage. That line is important. Close book question. So what you have to take, drainage systems of the floating roof should be inspected for leakage and blockage. If the drains are blocked, an accumulation of liquid can cause floating roof to sink or be severely damaged. This is especially true when the roof is sitting on its legs or has poorly contoured deck that does not allow the good drainage. Proper operation of check valves in drainage sumps should be verified on a regular schedule, especially for those in fouling or corrosive service. Okay. Then please go to the auxiliary equipment. Suppose you have a buried piping going from tank, 6 to 12 inch, you have to excavate seat. Check the condition whether any soil corrosion is happening on the pipe. When external piping inspection of the buried tank piping is specified, the soil around the pipe should be dug away 6 to 12 inch to allow for inspection. A soil corrosion may be especially severe in such points. So generally 6 to 12 inches is considered as a soil tear interface. After the pipe is exposed, it should be thoroughly scraped and cleaned to permit visual and UT examination. Then pressure and vacuum 8 to 11 to last line. Pressure and vacuum breather should be inspected upon 5 to see they are not plugged. So what do you check? Highlight the entire paragraph. That the seat and seal are tight and our moving parts are free, not sequent. Last line is important. Plugging of the discharge side screen and the buildup of solids on the pallets are common problems. This is open book question. Then flame arresters. This is again open book question. Flame arresters should be opened at appropriate intervals, and the screens and the pallets should be visually inspected for cleanliness and corrosion. Why they will fail? Because of the birds, bees and mud daubers occasionally plug arresters. That is important. Bees and mud daubers. That is a close book question. Solidification of vapor from the stored may also restrict the flow area of the flame arrestor. This one is closed book. Bees and mud daubers. Flame arrestor na fire ஆச்சுன்னா உடனே இது பண்ணுது. உடனே வந்து ஆட்டோமேட்டிக்கா ஆப்ரேட் ஆகும். ஃபோம் ஸ்ப்ரே பண்ணும். Okay. Tank bottom. Highlight the 8311. A tank bottom can be inspected externally through tunneling or lifting a tank. With the technology developments in the industry, tunneling under the complete lifting a tank just for soil side corrosion, which should normally be avoided. Lifting or tunneling methods may be used when justified by other consideration, just as besides the code the soil side. Okay, generally making a tunnel at the bottom side for the bottom is not preferred. These are not important. So please go to the page number 64. Roof rafters. So how we will check the condition of the roof rafters? On the roof plate, because roof plates are laid on the rafters. You cut the roof plate, a coupon, and lift that, then you can see what is the rafter condition. Rafter is corroded or not. Coupons approximately 12 inch by 12 inch in size can also be removed from the roof to check for the underside corrosion and rafter condition. All coupons should be round and have rounded corners. No square corner coupon should be cut. Generally, coupon cutting is allowed in roof as well as bottom plate. Suppose you are doing MFL, still you have a doubt how much it is happening on the soil side. You can cut a 12 inch by 12 inch, 1 foot by 1 foot plate and check the bottom side. Then after we will reweld it. ராப்டர் எப்படி வந்து இப்போ ராப்டர் மேல தான் பிளேட் சீட் ஆயிருக்கு, அங்க கொரோடா ஆகுதுன்னா அந்த பிளேட்டை கட் பண்ணி ஏதாச்சும் ஒரு இடத்துல கட் பண்ணி பார்த்தா, ஏன்னா எம்எஃப்எல் வந்து ஜென்ரலி நாட் பாசிபிள் அண்டர் ரூஃப் பிகாஸ் ஆஃப் த லோ திக். பாட்டம்னா வி ஹேவ் எ பாட்டம் பிளேட், ரூஃப் வந்து ஃபெயில் ஆச்சுன்னு வச்சுக்க, வெயிட் தாங்காம இட் வில் காஸ் சீரியஸ் இன்ஜுரி. Yeah, UT, suppose if you have a, so UT will check only the roof thickness, it will not check the rafter condition. If you see what is the corrosion happening between rafter and the roof, one area we can cut a sample or water inside. Suppose you have a doubt how it is, sometimes you have to check it. Okay, 8336 anti-rotation devices. Most floating roof tanks are equipped with guides and stabilized to prevent rotation. There will be a pipe like this. It will not allow that roof to rotate, the floating roof. Floating roof should not rotate, otherwise seal all will break. These gates are subject to corrosion, wear and distortion and should be inspected visually. If the gates are distorted or the roof is no longer in alignment with these gates, the roof may have rotated excessively. The shell should then be inspected for deformation or other defect as previously outlined. So if it is roof is rotating, you have to check whether cell is deforming or not. Open book question. Roof drains. Roof drains on floating roof can be designed in many ways. They can be simple open drain pipes or swing joint or flexible hose drain that keep water from contaminating the product. Roof drain shall function properly. If not, certain types of floating roof can sink or not function properly. These are not important. Then please go to the page number 69. Page number 69, first 4 lines. Page number 69. Inspector should be alert to accumulation of dry pyrophoric material self-igniting when exposed to ambient condition during inspection. These accumulation may occur on the tank bottom, in the seal rim space areas, on the top of the rafters. Such accumulation that cannot be cleaned prior to inspection should be kept moist to reduce the potential for ignition. We have to keep moist. Then preliminary visual inspection. This paragraph last line is important. Open book. Floating roof tank should be examined for loose or broken seal hangers and shoe bolt heads that can cause abrasive wear. That is important. Open book question. These are repeat actually. This will all repeat. Then please go to the page number tank bottom inspection, page number 71. Again, there is a coupon cutting. 8452, second para. Representative section or coupons, minimum 12 inch each way may be taken to confirm the results of MFL or ultrasonic. Suppose you have a doubt whether MFL is RRR, you can cut a coupon and check actual thickness. The increasing accuracy of MFL ultrasonic scanning and other automated methods makes coupon removal less useful, especially considering the time and expense associated with replacing the coupons. Coupons are recommended for assessing the roof causal of the soil side portion. Open book question. Then page number 72, statistical sampling. See, what is meant by statistical sampling? Suppose if you have a large tank bottom, it is difficult to scan the entire tank bottom. But if you have only uniform corrosion problem, no need to scan the entire bottom. Only some 10% we will scan it randomly here and there. Okay. Statistical method also available for assessing the probable minimum remaining metal thickness of the tank bottom, and the methods are based on the sampling of the thickness scanning data. The number of measurement taken for statistical sampling will depend on the size of the tank and the degree of the soil side corrosion. That is important. Open book question. So how much percentage you are taking depends on the size of the tank and the degree of the soil side. Typically 0.2 to 10% of the bottom should be scanned randomly. That is closed book question. Yes.
Sir, underneath the bottom plate, how we will come to know whether this is uniform fittings or the localized fitting? Underneath the bottom plate.
No, under the bottom plate, based on the previous experience, you think it is only uniform corrosion is happening, then only we can go for a statistical method.
Based
there is
on
a
the
low,
based on the
yes,
previous experience.
yes, based on the previous experience only it is.
Okay.
If there is a localized person fitting, you cannot go for statistical method.
Yeah, that's what my question.
Yeah, yes. Okay. Then pitting. So how we will measure the pitting? Again, MFL, suppose you have access to the pitting, top side pitting, you can measure the depth of the pitting by using a pit gauge. We can use a pit gauge. Then highlight this one. Pits can sometimes by scratching the suspected areas with a pointed scraper. When extensive and deep pitting is located and measurement the pits are necessary, the areas may be abrasive blasted first, although it should be noted this process can also create holes or open existing holes. Then the last line is important. The depth of pitting can be measured with a pit gauge or with a straight edge and a steel rod for large pits. Many pits are very close. We can use a straight rod and measure. Seams in riveted tanks highlights. Seams in riveted tanks can be checked by running a thin blade, scraper or knife along the riveted seam. So any gap is there. Now we are using riveting lapping. Okay. If the seam is open, the scraper will pass into the opening and disclose the separation. Rivet should be checked at random for tightness. Then highlight the page number 74, first two lines. The area of highest stress in flat bottom tank is commonly at the shell to bottom joint detail. Shell to bottom only the highly stressed area. Page number 74, first two line, tank shell. Now, when you open, generally, if you take 575, majority of the question will be open question. We will ask you about the particular subject, for example, tank bottom, tank shell. So during exam, you have to check this content page. I think here it is not working. Okay. The content that PDF they are using is works. So just to where is it, they will arrange it very neatly. If you say index, bottom inspection, shell inspection, roof inspection, that area we have to search it. Yeah, page number you can choose it. Suppose I enter the page number, but the control F will not work. Page number you can choose. Then that is not exam. Yeah. Huh? But if the search working, then that is not exam. Okay,
But
they will
the page
deactivate.
number, I
Yes.
think page number is also will not work because in the exam, the only required portion data only will be available.
No. Just they are asking that we can enter the page number.
Yeah, but it won't help us.
It will not help us actually.
Yeah,
Page number, because it is very difficult to remember how many page numbers you will remember. But they are using, they are not giving, but 575 they will give the entire code book. 650 what they have given to you. I think little bit more because in chapter 5 in 650 we removed some unwanted pages, but they will give the entire chapter 5 main code. 650.
In the exam, they give all the code.
No, they will not give all the code book. There is one thing called the exam version by APA. Exam version is only required for exam only they will give. But you can see the body of knowledge. For example, yesterday we did 651. 651, 3 chapters are not covered. That will be removed from the exam version. Same. Best is click the content particular, it will go directly in that page. Just you have to scroll some 3-4 pages here and there. That's all. One minute, I'm coming. Okay. So 8.4.7 page number 75. Testing for leaks. These are the nine important. Right, linings 848, third line. The most important concern to ensure that the lining is in good condition, there is proper position and does not have holes or cracks. With alloy steel or more rigid metal linings such as nickel and monel, inspection should be made for leaks or cracks in the lining joints. A careful visual examination is usually required. If there is evidence of cracking, the liquid current examination method can be used. The magnetic examination method cannot be used on non-magnetic. See, here we are talking about the shell lining, not for the bottom line. Shell, sometimes if we have storing highly corrosive material, we can go for a metallic lining, like a stainless steel plates, cladding, we can go for it. They are talking about that line. With the rubber, synthetics, glass, or organic and inorganic lining, the general condition of the lining surface should be inspected for mechanical damage. Holes in the linings are suggested by bulging, blistering, or spalling. A thorough method of inflation leaking such linings use of high voltage, low current electrode that is passed over the non-conductive lining, while the other end of the circuit is attached to, so that is we call it as a Holiday spark test. This is commonly called a Holiday detector. An electric arc will form between the brush electrode and the steel tank through any holes in the lining. Caution should be used so the examination voltage does not approach a value that might puncture or damage the lining. When employing Holiday testing on lining that have been in service, the inspector should be aware that there may be false readings if the lining is conductive as a result of being immersed in the product. As a consequence, Holiday testing may not be. See, remember in yesterday 652, in service, if you are going for lining, first you have to dry the lining. Because if there is a moisture absorption, water absorbed inside, it becomes conductive. Okay. Then highlight this one. கிளாடிங்னா உள்ளார ஸ்டெயின்லெஸ் ஸ்டீல் பிளேட் கொடுக்கணும். ஆமா, ஷெல்லுக்கு இது ஏன்னா கான்டாக்ட், அதாவது பேரியர்னா வந்து ஷெல்லும் அந்த ப்ராடக்ட் டச்சில் இருக்கக்கூடாது, குறைஷன் அவாய்ட் பண்ணும். எஸ்எஸ் அலுமினியம் போக மாட்டாங்க ஜென்ரலா, ஸ்டெயின்லெஸ் ஸ்டீல் வேற ஏதாச்சும் குரோமியம் பேஸ். ஆமா, வச்சு வெல்ட் அடிக்கிறது, பிளேட்டை வச்சு வெல்ட் அடி, பிளக் வெல்டிங் அடிக்கிறது. Glass lined tanks are especially susceptible to severe damage that cannot be easily repaired. So what is the, sometimes if you go for glass lining, it is very difficult to repair. Okay, that's why glass lined vessels should be inspected very carefully, because sometimes inspection can damage the line. Another thing is glass lined vessel tanks, there should be a caution. It should never be hammer tested. There should be a caution sticker they will put, a glass lined vessel, never hammer test like that. Glass lined vessel should never be hammered or subject to any impact on the inside or outside, because of the lining can crack. It is advisable to coat them with a distinctive color or to stencil a warning against striking them prominently on the external shell. It is important to keep spillage of the outside of the glass lined tanks. Okay, these are not important, that's only important. Then please go to the 84101. Internal equipment. The third line, highlight this one. This is open the question mark. Except for cast iron parts, the coils and support should be ultrasonically examined or hammer tested. Coil should be tested hydropneumatically for leaks. Wet steam coil should be inspected for condensation grooving in the bottom of piping coil using radiography or ultrasonic testing. At that line is important. Wet steam coils only you have to check for grooving in the bottom of coil by radiography or ultrasonics. Then swing lines. Next 8410-2. So what is the swing line means? That the drain lines which have swing joints. Swing lines of floating roof tanks may be equipped with the pontoons, rollers, or tracks. The pontoon should be hammer tested and checked for leaks. The thickness of the pontoon wall can be measured by ultrasonic testing. The tracks and alignment rollers should be inspected usually for corrosion, wear, and distortion. Then next page, page number 17, tank nozzles and piping. This is important close book question. This is important close book question. Gasket surfaces of opened flange should be checked for corrosion, and the flange face should be checked for distortion by using a flange square. Then drain line. How we will check the drain line is leak free? So we have to do the hydro test. During the shutdown, the drain lines, the floating roof drain lines, we have to do the hydro test. They will do two pressure. First, they will test with high pressure 30 psi, then with low pressure. Because some swing joints are high pressure, they will not leak. Because of the pressure, they will become tight. But a low pressure, they will leak. So we have to do two hydro test of the swing lines. Okay. For the drain lines, including the joints, can also be tested for tightness by pressure testing with water. If designed for internal pressure, it has been found that two-stage hydro-pneumatic test pressure is desirable. The first step is to test about 30 psi gauge pressure or for approximately 30 minutes to detect any leaks in the pipe, hose, or rigid joints. The pressure is then reduced to approximately 5 psi gauge for another 30 minutes to test for the tightness of the swing joints. Swing joints may be self-sealing at higher pressure, but will leak at the lower pressure. That is open book question.
Sir, what do you
Then-
mean by swing joint?
Swing joints, okay, I will show you.
And the test pressures are
Pipe to
for,
pipe joints, pipe to pipe the external floating roof joints. Okay, let us see if any video is there in.
the test pressures are for internal or external spools?
It is for the internal piping, not for the storage tank. See, the floating roof will have a drain line.
Okay.
That is for the floating roof drain line, not for tank. Floating roof drain joints. Right. See, these are, I will share you. You can see here. Right. So these are called swing joints. Will look like this. Okay, so this picture is not clear. So you can see here. So this is a flexible swing joints. So this joints, where there is a direction change, they will use a swing joint. So we have to check this line, not the tank, because if it is leaking, so the leakage, it will mix with the tank, storage tank content. So we have to periodically check during shutdown, they are leak free.
Oh, noted.
Right. Then highlight this one. If water is not available and the roof of the tank is reasonably airtight or can be made so, a carefully controlled air test using a air pressure not exceeding 2 inches of water pressure may be applied. So suppose water is not available. This is for atmospheric tank testing. This is okay. This type of test is very little use of strength test and is used only to inspection of the leaks. For this test, indicator solution applied to outside surface of any suspect areas of the tank, shell and roof weld seams so that the air escaping through. So we can entire tank we can go for a test. It is given in this also 650 also. 2-inch water pressure. That is open book question. Then these are not important. Then please go to the page number 82, 923, evaluation of bubble examination pressure. For this method, the inside surface of the bottom is coated with an indicator solution. Air at no more than 3-inch water pressure injected by a hose under the bottom of the tank through the clay seal or through a drilled or tapped hole in the bottom. So what is the pressure you should know? That is the open book question actually. Here 3-inch water pressure, that is for the bottom. If you want to test the entire shell and roof, 2-inch water pressure, you can see here. This is 2-inch water pressure. Then vacuum box 924. A vacuum is developed inside a box by means of a vacuum pump or air ejector connected to the box through the hose. Leaks will appear as bubbles when leaking through the glass top of the vacuum box. This method requires a minimum vertical clearance of 6 inches between the bottom and any obstruction of the placement of device. Highlight this one, 9.2.4. Then please go to the evaluation by under bottom injection, page number 85. So you can use a tracer gas also. Another method being used successfully is the injection of inert gas with a tracer element under the tank, page number 85. An advantage of this method is that welded repairs can be made immediately with the inert gas under the bottom, and a recheck can be made immediately after repairs. So what inert gas we are using? Third paragraph. Welding grade helium is a common gas used for this application. Then highlight this next paragraph. This method of testing is applicable to 100% of all bottom plates, welds, bottom to shell, patch plate welds, clip attachments, sump pumps, weld scars, anything we can check. So this is actually the helium tester. Page number 91. Repairs to riveted and bolted tanks. Highlight this also. Repairs to these tanks may also be made by welding if the weldability of the steel is first confirmed by physical testing. Even riveted tank you can made by welding. A leaking rivet seams, rivets can be caulked, re-riveted, welded or abrasive blasted or coated. Any coating or repair material should be allowed to cure as recommended by the manufacturer before the tank is returned to service. When spot or riveted seams are sealed by welding, the rivets and shields should be caulked for at least 6 inches in all directions from the welding. We are making welding from welding 6 inches, you have to put a sealant. That is important. Open book question. Now, bottom repairs. So how much, see when they are new, when you are installing a new bottom, we can see the next page, there is a sketch. This is a new bottom plate. It is a old bottom. So we will install the shell and we will fill with the sand, clean dry sand here. So how much outside we have to fill? At least 3 inches more if bottom shell is seriously corroded. This is important. A perimeter layer, previous page, 10.2.4. So a perimeter layer of clean sand fill, metal grating or a concrete pad should be installed under at least 3 inches beyond the projection of the new bottom, so that the shell is supported on the foundation through the new bottom. So 3 inch outside also you have to fill it with.
We can do this only if we don't do the follow the cathodic protection, right, sir?
No, if a bottom is severely damaged, even cathodic protection, yeah, generally if it is cathodic protection, bottom side.
Because otherwise we need to remove the bottom. We can't follow the 3 inch extra height from the previous base, right?
No, you are confusing many things actually. Okay, this is when the bottom is severely damaged due to various reasons. It may be due to the bottom corrosion or top side corrosion. It may be combination of both, which repair is a waste. Repair will take a lot of work. Instead of we will go for a replacement of bottom.
Yes, sir.
Yeah,
Sir,
that,
my
yeah.
question is not that. My question is,
uh,
like, if you want to keep the cathodic protection for the new bottom, we can't.
uh.
We need to remove the old bottom, right? Otherwise,
No, if
it's
you are
gonna be.
using a sand pad in between,
Yep.
old bottom removal is mandatory. Because if you put the, see, you can see the cursor here. If
Yes,
you
sir.
put
Yes,
the
sir.
anode here,
Yes.
okay, instead of protecting the new bottom, sometimes the current can be go for the old bottom. That possibility may be there. So you have to remove the old bottom. But if you are using a concrete pad, generally complete removal of old bottom is not necessary because concrete is not a conductive material.
Okay.
Okay,
So if you use
can,
concrete, we don't need to remove it. If you use sand,
no,
we
no
can-
need to, if you sand, you have to remove the old bottom completely.
Okay, sir. That's what I want to just clarify.
Okay,
myself. Thank you,
okay,
sir.
right. 3-inch we have to this one. Yeah, 3-inch outside because it has to hold the weight of the bottom plate. So we have to go from the shell to, see, this is your shell to bottom edge. From that 3-inch outside, we have to fill. You can see here at least 3-inch more. Your bottom shell is seriously corroded. We have to 3-inch outside also. You have to put here pad. Then please go to the page number 94. Non-metallic roof plate. Even soft patches are allowed. You can see the sketch here. You can put a soft patch. Like our buildings, they are using some building soft patch. Even our buses, they are using a soft patch to avoid leakage. Yeah, you can use a soft patch. It is considered as a repair, one of the repair method. Tank roof, mastic roof, you can use, or you can use this. So this is important, but it is leaks in roofs can be repaired by a non-metallic carbon fiber metal or by soft patches that do not involve cutting, welding, riveting, or bolting of the steel. Soft patches can be made from variety of materials, including rubber, neoprene, glass cloth, asphalt, and mastic or epoxy sealing materials. The choice depends on the contents of the tank and the service condition. The patching is applied in much same manner as the similar patching would be applied to the roof of a building. So we can use a soft patch. Open book question. Then please go to the page number 95, safety consideration. This is important. Soil foundation, the middle line, that are washed out of settled or settled under the bottoms of atmospheric storage tank can be repaired by pumping sand, drilling mud, clay, lean concrete, or similar material under the tank. So suppose soil foundation is corroded. So if the corroded foundation, we have to correct it. How we can correct? By pumping sand, drilling mud, clay, or lean concrete. We can put additional concrete or mud. We can use it to filling this one. That's all 575. Yeah. These are not important, I think. 1 minute. Similar service. Please go to the annexure B. Similar service evaluation table. Maybe sometimes, maybe question similar service. You remember similar service we have seen in 653. Here there is a comparison table. For example, stock can range from nil to very high. For hydrocarbons are typically % 1 mil to 3. Temperature, water bottom design, but these are not important for exam. Okay, so this is a completion of 575. So we have completed all the main codes. Okay, now I will start a common code now, just to start introduction. Afternoon, we will review question of 651. 651 we have completed, right, yesterday? 652 and 575, we will do afternoon. Let us go for a common code books. Just half an hour we will go. So if you see common code books, we have 3 code books. 577 2020 edition, ASME section 5 2019 edition. To section 5 we have only article 1, 2, 6, 7 and 23, and section 9 2019 edition. Okay, this common code books will have around 20 questions, sometimes a little bit more than 20. Okay, If you have already a welding and NDT knowledge, these code books are very easy to score. Now, I will start with the NDT section 5, then we will go to the 577, then we will go to the section 9 last. So first, NDT, generally, how many questions they will ask? Around 8 to 10 questions will be asked in the NDT. NDT will have, generally in AP exams, NDT questions will have around 8 to 10. So the general pattern is PT, there will be one question. Which code you have to refer? ASME 5. If you take MT, there may be one or sometimes two questions. Again, we have to refer ASME 5. RT is the most important. RT will have 3 or sometimes 4 questions. Again, here you have to refer ASME 5 as well as API 577. If you go UT, then it will generally 2, very rarely 3 questions. Here also you have to refer ASME 5 and the API 577. There are additional information in 577. Apart from that, visual testing, ACFM, eddy current testing, leak testing, all together may be 1 or sometimes 2 questions. This information is available only in API 577. Please write this. Is it okay? So please take section 5 first. We will go through the section 5.
ஒரு 2 நிமிஷம் சார் புக் எடுத்துறேன் சார்.
Yes. First, what are the common things in NDT? So NDT, we are generally the questions that I told you: PT, MT, RT, UT. Okay. Now we have section 5, article 1. Article 1 is the general requirements. Article 2 is the radiographic testing. UT is not part of our exam. Article 4 and 5 are RT, the UT actually. Then Article 6, connected testing. Article 7, magnetic particle testing. And UT, we have only thickness gauge, SC 797. First, let us start with Article 1. Article 1, only one paragraph is important. Rarely exam question is asked, very rare. So the regularly asked the one paragraph question is, how NDA personnel shall be qualified? Okay, generally you will answer SNTTC 1A. That is not a correct answer. Okay, what code says NDA personnel shall be qualified in accordance with the reference code requirements. What is meant by reference code? If you are using storage tank construction, 650. If you are storage tank in service, 653. What 650 says, in case of construction, you have to follow. Suppose 650 says follow ASME section 5, then also it is not SNTTC 1A. The answer is they should be qualified in accordance with the employer written practice. The employer means the technician who is appointed, who appointed the technician. The contractor, NDT contractor should write a employer written practice. By employer written practice only he should qualify the technician. How he will write employer written practice? Either by SNTTC 1A or CP 189 or ACC. So most of the people answer same. how the NDA personnel will be qualified, then they will answer SNTTC only. SNTTC only is not the correct answer. The most accurate answer is a reference code. Suppose if you want to qualify NDA personnel as per section 5, how they will qualify, then the answer is employer return practice. Suppose they ask question, how you will write a employer return practice, then only the answer will be SNTTC only. Suppose they are asking question, NDA personnel shall be qualified in accordance with which of the following. So there is no reference code, there is no employer return practice, then you can choose SNTTC only or CP only. Okay. So please highlight this paragraph. Page number 1. This is a closed book question. Page number, please take Article 1 general requirements, page number 1.
Please share your screen. So Article 1, page number 1. This is the Article 1 general requirements. For those documents that directly reference this article for the page number 1. ASME section 5, page number 1. Qualification of NDA personnel. The qualification shall be accordance to the employer return practice, which shall be in accordance with one of the following documents. SNTTC 1A, still they are following 2016. CP 180 and 2016 edition, or ACCP also we can do. Very rarely asked, but please remember, if there is a reference code answer is there, that is the most correct answer. If it is not there, and the employer return practice also not there, then only you will go for SNTTC 1A or CP 189. So don't think SNTTC 1A is the first choice. It is not a first choice, it is the last choice. Okay, you can see clearly. For those documents that directly refer this article, for the qualification of NDA personnel, the qualification shall be according to employer return practice, which shall be in accordance to one of the following. How will write the employer return practice? By SNTTC 1A or CP 189 or ACC. Right now, so before going article to radiography, just briefly, I will compare the 4 NDT methods so that you can have some idea. Please remember, exam question will be based on the code requirements, not on your general knowledge about the NDT. Sometimes what you think is different from what is said in the code. Okay, so you have to, that's why sometimes people say, sir, NDT questions are easy, but if you see the final result, there is no more, they not scored much in the NDT. The reason is what they are thinking is different than what is given in the code. First one, who will do the NDE? I told you it is not NDT, it is NDE, non-destructive examination. So it is the contractor. It will be an organization. Okay, the organization, we call him as a contractor, NDT contractor. What he has to do first, he has to write a procedure for each NDE method. He has to write a procedure. And the procedure should be approved by the owner of the. So who is his client? He has to approve by the owner. Once the owner approves the procedure, then the procedure must be qualified. How will qualify the procedure? By taking a plate or pipe, whatever the taping is this one, a plate with a weld with the defects. Okay, sometimes the owner may give the plate or pipe. So, okay, I want to use this your procedure and to do NDT in this one. So you have to find out all the defects. Yeah, demonstrating. If we can find out all the defects, then the procedure is qualified. Once procedure is qualified, procedure will have essential variable and non-essential variable. Like same ASME section 9, section 5 also have essential. So what is the essential variable? Any change in the procedure which requires again a qualification of procedure, requalification of procedure means essential variable. For example, NDT technique is an essential variable. Method is different, technique is different. PT is a NDT method. In PT method, we have 6 techniques.
solvent removable, water washable, post emulsifiable. These are called a technique. You cannot change the technique. You cannot write in your procedure solvent removable, or you cannot do water washing. These are essential variable. Any change in essential variable requires a requalification of the procedure. But if you change in a non-essential variable, for example, post cleaning, some small things, any change in the non-essential variable requires a revision of the procedure, not requalification. See, in code language, revision means a different meaning. Requalification is a different. What is meant by revision? Only document correction. Requalification means you have to again write a procedure and demonstrate it. That is called as a requalification. As per section 5, PT, MT, or UT. These three require procedure and procedure qualification. RT require procedure, but does not require procedure qualification. So as per section 5, RT, there is no essential, non-essential variable table. But PT, MT, UT, we have essential and non-essential variable table. Point number 1. About the procedure. Is it clear? So which of the NDT method does not require procedure qualification? Answer is radiography testing. Next one, when you are doing NDT, we need to prepare a surface. Surface preparation is required. Again, which of the following NDT method does not require surface preparation? Again, answer is radiography testing. Radiography you can do in painted, rusted, any surface we can take radiography. But PT, MT, VT, visual testing, and UT, all we need a surface preparation. If you take PT and MT, how much surface you have to prepare? Prepare means clean. 1 inch on both sides, 1 inch as per section 5, 1 inch on both sides of the weld. UT, how much area you are going to scan? That much area you have to prepare. Okay, so that is about the surface preparation. Then next one is temperature. At what temperature we can do? PT temperature is specified in the code, 40 to 125 degrees Fahrenheit. That is the temperature range allowed by the section 5. If you put it in centigrade, 5 to 52 degrees centigrade. If you qualify a procedure in any temperature, for example, what is our room temperature now? It is 25 degrees centigrade. If you convert it into Fahrenheit, it will come around 80 degrees Fahrenheit, 77 or something it will come. Okay, 80 degrees. How to convert centigrade into Fahrenheit? Multiply by 1.8 plus 32. So how much it will come, calculate? Yeah, plus 32. 25 multiply by 1.8 plus 32. Plus 32. So that is 77. And that's why I told it will around 80 it will come. What is the room temperature centigrade? Multiply by 1.8 and plus 30. Now, so 80 degrees, if you are qualifying procedure in this room, so 77 degree Fahrenheit accurately, the procedure can be used from 40 to 125 degree Fahrenheit. Okay. But if you want to use a procedure more than 125 degree Fahrenheit or less than 40 degrees Fahrenheit, you have to qualify the procedure again at that temperature. Suppose you want to use the procedure in 200 degree Fahrenheit. So you have to qualify the procedure, you have to heat the plate to 200, then you have to qualify the procedure. That is for the PT. So many exams this question was asked. What is the temperature for PT? 40 to 125. Coming to MT, there is no temperature specified in the code. You have to follow the particle manufacturer recommendation. Particle means the liquid or magnetic particle, chemical. The recommendation only you have to follow. Again, if you want to go outside the recommendation, you have to qualify the procedure at that temperature. Now coming to the RT, again there is no temperature specified in the code for taking radiograph. So as long as you can protect your cassette from the heat, you can take radiograph. There is no temperature, but for film processing, there is a temperature given in AP 577. Film should be processed at 68 degrees Fahrenheit. 68 or 20 degrees centigrade, 68 degrees Fahrenheit. Developing should be 5 to 8 minutes. Come to the UT, very important. Okay, the calibration.
what temperature you are calibrating for thickness gauge. We are talking about the thickness gauge. And the part temperature, calibration temperature, both should be same. But a deviation of plus or minus 25 degree Fahrenheit is allowed. Many exam, again, this question is asked. What is the temperature difference allowed between a calibration block and the test part is 25 degree Fahrenheit variation. It can be plus or minus. Where it is given 577. AP 577. I told NDT is covered in section 5 as well as 577. So I will just repeat it. PT 40 to 125. MT manufacturer recommendation. RT for processing 60 degree Fahrenheit. UT temperature difference allowed between calibration block and a test part 25 degree Fahrenheit. Is it okay? Right. Now about the I already told about the surface cleaning requirements and already told about the temperature. Third one is calibration. All NDT requires some calibration. Then the first question, which standard you have to calibrate? Answer is national standard. It is not an international standard, not a ASM standard, not a ASNT standard. We have to calibrate only to a national standard. இதே ஆஃப் பண்ணிட்டான் யூபி சரி அவங்கள பார்க்க ஒரு நிமிஷம். Okay, I will continue class another 5 minutes because there is some small UPS issue. Okay, without display.
அதுக்கப்புறம் என்ன சார் சொன்னீங்க?
Right. Just a minute. So let us complete the calibration.
Sir, now you said you're saying about something national standard, sir. After that,
Yeah,
it was
calibration only. I am repeating, no problem. Okay, so calibration. First question: which standard you have to calibrate? National standard. It should be calibrated to a national standard, not ASME, not ASNT, not international. Okay, it was asked in one of the old exam. Traceable to a national standard only calibrate. Now, what is the frequency of calibration? Generally, it will be 1 year. Generally, any calibration, every year we have to calibrate. When the condition 1 year comes, there will be 2 additional conditions also will come. The first one is, if you are doing any repair before 1 year, you have to calibrate it again. Next condition is, if you are not using the equipment for more than 1 year, suppose 2 years you are not using, that's why you are not calibrating. Before using, you have to calibrate it again. You have to calibrate. If there is no calibration certificate, then before using, you have to calibrate. But there are exceptions. If you take PT, which one you will calibrate? PT, when you are using color contrast conductance test, it will have sufficient light. What should be the light? 1000 lux. Okay, so 1000 lux, how we will calibrate using a light meter?
Sir, it's
yes, please.
1076.
Yeah, it is now changed. Okay, so this is accurate value now. They are using 1076. Okay, so if you use a fluorescent, then the fluorescent light intensity should be 1000 microwatt per centimeter square. Okay, that also you have to calibrate with the radiation meter. Okay, this calibration we have to do every year. First one. Now coming to the MT, there is an exception. As per section 5, yoke should be calibrated daily. Daily you have to calibrate it. Okay. Yokes or permanent magnet you have to calibrate daily. Another exception is radiography densitometer. Densitometer should be calibrated every 3 months. Okay, every 3 months you have to calibrate. So generally calibration means 1 year, but there are 2 exceptions. Yokes and permanent magnet should be calibrated daily, and densitometer should be calibrated every 3 months. Okay, so then we will go to the article 2, but because of the project is not working, there is some repair work going on. So we will continue afternoon. 2 o'clock we'll continue. 2 o'clock we'll review the questions, not this one. Yeah. Okay.
Sir, one doubt. I have one
Yeah,
doubt.
yes, ask.
For the MPI qualification, for the operator qualification, is there any position qualification is there?
Yeah, it is there in appendix.
Appendix, it is there in appendix.
Yes, if you, it is only applicable for dry powder.
Yeah, dry powder with the same
Yeah, if
question.
the operator is qualified in overhead, he is qualified in all positions. If it is tested in vertical, he is not qualified in overhead.
Oh, the same question came in API 570.
Yes, there is there, right there. We will cover it. Okay, we will see you in the afternoon session.
Sir, நான் கேட்கணும் டவுட் இப்ப கேட்டுறோம் சார்.
சொல்லுங்க.
சார் அவுட் ஆஃப் பிளம்ப்னா என்ன சார் இது?
அவுட் ஆஃப் பிளம்னஸ் அப்படின்னு சொன்னோம்னா எவ்வளவு வெர்டிகாலிட்டி எவ்வளவு அவுட் ஆயிருக்கு, வெர்டிகாலிட்டி எவ்வளவு அவுட் ஆயிருக்கு, அதான் அவுட் ஆஃப் பிளம்னஸ்.
ஓகே சார். பேண்டூம்னா சார்?
பேண்டூம்ங்கிறது அந்த கம்பார்ட்மெண்ட். பரவாயில்ல நான் முடிச்சிட்டேன். மத்தியானம் பண்ண சொல்ல, அவங்க ரிப்பேர் பண்ண சொல்ல. பேண்டூம்ங்கிறது அந்த கம்பார்ட்மெண்ட்டுங்க.